Hi team. Let's wait for Anisha as well. Then we can quickly get started. Also, for your information, tomorrow we do not have any class. Okay, so I'll be traveling, so we do not have class tomorrow. Hi Anisha, thanks for joining. Okay, so let's quickly get started. Let me start sharing my screen. Okay, so Arun got dropped off. Okay, maybe some issue.
So sorry for the delay, sir.
No problem, no problem. Yeah. Mm, okay, let's get started. Okay, so first thing is today our concept is to discuss on the difference between data frame, data set, and RDTs. Okay, so there are three different concepts in Spark. So just good to know concepts these are. So data frame, data set, and RDT. So as you already know, RDT means resilient distributed. Can anyone feel that? Resilient distributed data set. Okay, so in Apache Spark, right? So Apache Spark, you have these three APIs available. But how and when we supposed to use these things? Okay, so let's see about RDDs. Okay, so RDD means you already know resilient distributed data set, and this is the basic data structure of Apache Spark, right? That's what we discussed. This is the low level. Okay, so this is the low level distributed collection of data of Spark of data in Spark, and it's basically fault tolerant distributed memory abstraction. All these things. Yesterday I showed you an example, right? So how RDD looks like and how data frame looks like. Like RDD is kind of set of rows. Okay, just set of rows, and this data frame, right? It's a structured, well structured table. So it's a kind of table with rows, columns, and data types as well. Let's say there is a column called ID. That ID we should mention that okay, this ID column should be of this integer type. Name column should be of string type, like that. So we will mention that as well. Okay. So RDD is the basic data structure. You already know enough information about this RDD. Okay. So and I'm telling you that RDD we are never going to use in our product data engineering. Okay, so maybe small task we will other than that we will never going to use it, because RDD is low level API. Okay, but data frames are high level APIs. APIs means like Spark will provide you an interface. Okay, PySpark interface, so that you will go there and interact with that PySpark interface and create whatever the logic you wanted to create. Okay, but RDDs do not is a low level API. So if you are still with this API, you can do the whatever you want to do with the data frame or RDD or data set. You can still do with RDD as well, but it's not recommended, it's not optimized. So that's why Spark itself not recommending us to use these RDDs. Okay, if there is anything that you wanted to go into RDD, it's okay to go into it, but it's not recommendable. Okay, fine. Now let's see this. It's untyped in the sense like it's raw. I mean, how you read the data, it's very plain raw, and it do not have any types. Okay, types in the sense data types. Okay, so string is a data type, integer is a data type, float, boolean. Okay, so array, all these are data types, right? Different data types. But here this is just untyped, just raw. Okay, so raw object, that's it. Offers low level operations like map, filter, reduce. Okay, map means you know, right, how we will map. For every element you wanted to map something, you can go and map this. Filtering, you know, filtering. Reducing means you already know reduce, map reduce, all this kind of stuff, right? So you have to manually manage schema and optimization. See, here it is. So manage schema and optimization. There is no schema for this RDDs. Okay, this is low level. There is no schema. This is very raw. You can decide the schema now. Okay, you can decide the schema for it. But in case of data frames, okay, data frames, the schema is already decided. Okay, Spark can automatically create the schema for you. I mean, data frames also you can impose the schema you wanted to impose on top of the data frame. But the advantage is there are cases because sometimes you do not need to write the schema. You can just make that the infer schema is equal to true. That's it. It will, the Spark automatically impose schema on top of that data. Okay, but in nowadays you need to manually manage. Okay, Supports immutable distributed collections with the transformations and actions. That's what we discussed. It's immutable. Okay, more control but more coding effort. Simple. More control, more coding effort. So use cases when you wanted fine-grained control or working with complex data transformations that data frames or data sets can't do easily. If there is three concepts here: RDD, data frame, data set. If you cannot do any action with respect with using these data frames and data sets, then only go for RDD. Otherwise, never go to RDD because RDD is not optimized. RDD is not recommendable. But RDD, even though you work on top of data frame, in the internally it's divided into RDD only. But you yourself do not directly work on RDD. Let data frame work on RDD. Okay, so that's why this RDD is the most important concept. That's why we started with RDD. But when you move to the data frame, right? Data frame means rows and columns, table structure, right? This is not a relational database, but still Spark help you provide an API. API in the sense, so PhonePe, right? PhonePe provides you that interface, right? Because that's an API. Okay, if you open, if you, this is Google Doc API. This is interface, right? Interface, application programming interface. This is in Google Doc API. This is Gmail API. This is this Skills Marathons API. So all these are APIs. In the real world, right? Everything is an API only. Okay, so that's why I'm calling as low level API, high level API. Okay, so low level means you have more control but more coding. But high level means less. It's a good control only, but less code. Okay, so let's go with data frame. Now data frame is again a distributed collection of data organized into named columns. Okay, similar to a table in relational database or a pandas data frame. Pandas data frame, maybe you are not aware of this, but yeah, we can think of this relational database. Okay, relational database. Let's remove this for now. No. Okay, similar to a table in relational database. Table means name, column name, row name, column data type, all these things. Okay, now features. Schema aware. See, schema aware. Schema aware means it knows the schema. Columns have names and data types. Simple. It knows the schema. But here it's manageable. It's managed by us. You have to manually manage schema and optimizations. Okay. Now, built on top of RDDs. Okay, built on top of RDDs. Catch here. It's built on top of RDDs, but you can ask me, sir, you're not saying that it's not recommendable to go with RDD, but why we are going with data frame, which is built on top of RDDs. Here there is extra facility provided by this data frame, that is using Catalyst Optimizer. Okay, Catalyst Optimizer. What is this Catalyst Optimizer? Just remember this name for now. We have the things in the next slides. Okay, just remember this Catalyst Optimizer. What is that Catalyst Optimizer? We will discuss. This is Spark Queries Optimizer. Okay, but just remember that data frames are built on top of RDDs. Okay, now there is a Catalyst Optimizer that is helping these data frames to optimize the query that is submitted by the user to it. Okay, fine. Now supports SQL like operations like select, filter, group by join. So similar to SQL. If I show you the a sample, okay, maybe Thursday and Friday I'm planning for this sample practical classes on Spark. Okay, you will understand that it's plain SQL. Okay, so it's that good. Supports SQL like operation like select a star from table. That's it. Simple. Select a star from table. That's it. So it's that easy. Okay. Now language agnostic means works well with in Python, SQL, Java, and R APIs. Okay, so Spark is polyglot, and everywhere you can use this data frames. Okay, easier to use than RDDs, and usually much faster because of optimizations. Okay, what is that optimization? That is why this Catalyst Optimizer is help these data frames to optimize the query. Okay, use case for structured data processing where you want convenience and performance. Structured, if it's not structured, then we won't be able to build a data frame on top of that. It's scattered, right? The structure. But here, if it's structured, you can definitely go and use these data frames. Okay. Now let's go and see data set. Data set. Okay. Data set. What is it? A typed extension of data frame. Okay. Only in Scala and Java, not in Python. Okay. So it says that extension of data frame. So now first you have RDD, then you have data frame. Data frame is built on top of RDD. Now it says that This data set is extension of data set. Sorry, this data set is extension of data frame. Okay, and this data set is used only in Scala and Java, not in Python. Then if you are using PySpark, you cannot use this data set. Okay, because it's PySpark means Python plus Spark. Then you can never use this data set in PySpark, and we never use actually. Okay, so if you're a Scala developer, Java developer, then you can go and use it. But we are going with PySpark, and we never use, and I never used it, and I never saw any people using it. Okay, but just it's good to know concept. That's it. In interview, you might get this question. Let me know what is RDD, what is data frame, and what is data set. So that's why. Okay, it combines the benefits of RDDs, type safety, and data frames optimized execution. Okay, let's see what is this type safety and all. Okay, simple, simple. So you were driving your bike. Okay, so you know what's coming in front. Then you can escape that dangerous thing, right? You can escape that accident. You know, if you know that what's coming in front of you. But if you're driving by closing your eyes, can you escape that accident? No, right? So that's what this type safety is. So type safety means data type safety. So let's say you have a string column. Okay, name. Okay, what I'm trying to do is unknowingly there is a name column. Okay, name column. Let's say first name and last name column. Unknowingly, I'm trying to add these two columns. What is first name? What is last name? First name is string. Okay, last name is string. If can I add two strings? No, right? I cannot do it. Practically it's not possible. I cannot use. I can make 1 plus 2, but I cannot make a plus b, right? I cannot make it. So that's the type safety. If I go with data frame, it do not have that. It do not have it do not check that. And in the runtime, right, it will first compile the code. If everything looks good, it will compile the code, and while running the code it face that issue. But in data set, right, it will face that issue before only it will, so it will know the type of that columns, right, data type of that columns, and it will check for the type safety, whether these operations are okay to apply on top of these columns, these operations. So on top of string column, you're supposed to apply only string related things. On top of integer column, you're supposed to apply only integer related things. But if you're doing reverse, I mean vice versa. So on top of string, you're using integer related functions. On top of integers, you're trying to do some string related functions, which is not acceptable. That's what type safety is all about. Okay. Now, a strong typing. Okay, you get compile time type safety. That means before because you're seeing the road, that means before only you can analyze that dangerous thing, and you can just danger, and you can just alert the user who done the code. Okay, provides object oriented programming interface. Okay, it provides oops and supports both functional transformations like map, filter, and SQL queries as well. If you see map, filter, it's saying from RDD. Okay, and SQL queries from data frame. That's what it says, right? It's combination of both benefits from RDDs and data frames. RDDs has its own benefits. Data frame has its own benefits, but this data set combines both the benefits. Okay, optimized by catalyst like data frames. Okay, optimized by catalyst like data frames can interoperate with data frames easily. A data frame is a data set of rows. Okay, so it says data frame is a data set of rows. Okay, just remember that. Okay, when you want when we are going to use this data set is first thing is while we are working with Scala and Java only, and I am pretty sure that if you are going with PySpark in your entire career, you're never going to work with this data set. Okay, and when use cases when you want type safety plus optimized performance in Scala and Java. Okay, you are never going to use this, so you will never face this thing. Okay, either you will go with mostly 99.99% of your data engineering career, you will go with data frame only, but 1% you might go with RTT, few transformations. Okay, now just summary. Okay, so this is low level, this is high level, this is high level with the types. Okay, so this type safety, no type safety, yes type safety. Okay, so that means you can beforehand you can judge whether we can apply these functions on top of this column or not. Okay, schema. So there is no schema here, there is a schema here, and there is a schema plus type safety as well. Okay, so optimizations, no, because there is no catalyst optimizer here. Here there is, in both these places you have catalyst optimizer. Okay, languages Scala, Java, Python. This is Scala, Java, Python. This is Scala, Java only. Okay, ease of use. Harder because manual coding. Easier. Okay, so SQL like APIs. Okay, SQL. It's SQL, select a star from table. That's it. Literally on in Python with this SQL like query set, you can do that. Select a star from table. That's it. Okay. So easier plus type safe. Okay. So easier coding plus type safe as well. When to use this? Complex transformations. If you are unable to do any transformations using this data frame, then go for this. Okay. This is structured data and SQL queries. Most of the times you will have structured data and SQL queries. Okay. This is typed structured data in JVM. So simple. When you're using Scala and Java, then go with this data set. That's it. Okay. Now, now you might ask me what is type safety. I mean, just further information. Okay. Type safety means that programming language or system checks the types of data at compile time before the program runs to prevent errors. See, simple. Type safety means any program language. It could be Java, Python, C, anything. If that program supposed to throw an error before it runs, before it starts running, because you write an high level code. High level code means it's human readable. It's not mission readable. That high level code needs to be converted into mission readable. I mean, I told you, right? Bits. Mission never understand our words. Okay, mission will understand only bits, 0 and 1. That's it. So whatever you say it in 0 and 1. That's it. Now these things, right? This Spark and all, they need to convert this code. They need to compile this code so that will be made the system understandable code. Okay, low level code. Okay, then you should, if you while converting it will throw this, while compiling it will throw this error in case of type safety. Okay, if you are getting that error because you're not supposed to perform these operations on top of this, then it means you have type safety. If it's not throwing the error, then you do not have the type safety. Okay. Simple. It ensures you use the data right way. And for example, you cannot accidentally add a number to a string or call a function on a data type that doesn't support it. Simple. You cannot call a function that data type doesn't support it. If data type doesn't support that function, you cannot call that function. Simple. Okay. This helps catch bugs early and makes your code more reliable. Okay. That's it. In context of Spark, when you use an RDD, data is just a collection of objects, often untyped, like raw objects or rows. Okay, you can accidentally mix up types to do operations that don't make sense. Okay, you might try to treat a string as an integer, but Spark won't warn you before running. See, before running, you might treat string as an integer, but it won't throw an error before running. It will throw you error in the runtime. Okay, so maybe you work with some programming language, Java or something, C or Python. You will get to know this thing. So runtime and compile time, there are two different things. Okay. Now first it will compile, then only it will run that code. Okay. Now with the data set, the data has a specific types like a class or case class. You can think of class. Okay, that means string class, str class, or integer class or boolean class. Those classes. Okay. The compiler knows the type of each column or field and checks your code before running. Okay, if you try to do something wrong with the data type, your code won't compile. Your code won't compile. It won't even compile. So if you change the get function and that function is not supported with the data type, okay, then you cannot apply that function. It won't even compile. It will throw an error. Okay, now data frame is like a data set of rows without strong typing. Okay, it's easier but less safe in terms of data types. That's it. So data frame and data sets are almost same, 99.99% same, but the difference is only the type checks. Okay, type safety. That's it. Okay, now simple. Type unsafe means driving blindfolded. You might hit a wall, runtime error. Okay, so type safe means driving with clear vision. You avoid accidents before they happen. Okay, but here type unsafe means you might hit that wall. Okay. That's it. Simple. Now, any doubts in this RDD versus data frame versus data sets? Any doubts? I'll share this document with you. But any doubts?
No doubts, sir. No doubts.
Okay, cool, fine. Let's move on to this one more important topic. Okay, so this is Spark SQL engine and query plan. Okay, so the moment you submit your Spark job, right? Spark job, what happens? What happens in the background? How things work in the background? What happens? Okay, I told you about catalyst optimize, how it comes to the picture, what it will do. How I told you, right, in the Spark, data frame is more optimized using this catalyst optimizer. So what happens in the background? What are the checks it will perform? Okay, so now let's see. Okay, so you already know this. Spark has two prominent interfaces to work with data. So Spark SQL, Data Frame API, and Dataset API. So which is available only for Scala and Java. So this is not in our scope now. Only these two, Spark SQL and Data Frame API. Okay, so with these two, we also have this dataset API, but Data Frame API and SQL. Okay, SQL in the sense like data frame API. I'll tell you the small difference. SQL means you can directly go here and write select a star from table. Okay, select a star from table. That's it. But here you need to do some Pythonic functions, Python way. So you cannot do directly go and write the select star from table. You need to do some Pythonic way. Okay, so that's thing. And this Spark SQL is combined with ANSI SQL. Okay, so the real time relational database systems you have, right? Relational tables and all. So though similarly, same SQL you can use in this Spark SQL. Okay, data frames are Python functions, and they allow you to implement functional programming techniques to process your data. Okay, simple. So the data from API internally uses dataset APIs, but these dataset APIs are not available in PySpark. Okay, so PySpark these dataset APIs are not available, and you will never going to use this as well because only in Scala and Java you're going to use this. Okay, and by the way, Scala is very fast, very fast. Okay, so compared to PySpark, Scala is very fast, but it's not that user friendly in the sense like you need to have some more experience, some more understanding on the concept. So I'd say mostly everyone will prefer this PySpark. Okay, if you're using Scala or Java, you can directly use this dataset APIs, but Spark recommends using data frame APIs and avoiding using datasets. Okay, simple. Okay, so you can almost do everything using data frames, and you might never see a reason to go with dataset or arrays. Okay, almost everything you can go with the data frames. Okay, so for example, the dataset is not available in PySpark, so they did not ask any. I mean, this is for certification related. I'm not sure anyone planning or this or not, but in certifications, people might think like I remember someone asking me in one-to-one class or something. Someone asked me this question. So in a certification and all these questions you won't get if you are planning for any certification. This dataset related side you won't get. Okay, so we can write Spark code using data frame APIs or write using SQL expressions. Simple, straightforward. Spark looks at the code in terms of chops. That's what we discussed, right? So the moment you write a code, it won't start. It's a lazy evaluated. Why? Because of the actions, right? The moment it sees an action, then only it will start job creation. We discussed it. An action is equal to one job. One action is equal to one job. Okay, so for that job from starting to end, what are the steps involved, what are the stages involved? Okay, so accordingly Spark will decide those stages. Okay, they assign the task to the executive. It will start the plan, right? DAG, direct acyclic graph, all the stages involved, and what are the transformations, wider transformations, narrow transformations, all these things. So everything is planned here, right? So that's what it says here. Okay, so similarly if you write a SQL expression as well, Spark consider SQL expression as a one job. Okay, so for that one job it will create this tag and all. Spark code is nothing but a sequence of Spark jobs, and each Spark job represents a logic query plan. Yes, right. So the moment you say select a star from table, so it's a plan. We need to create a logical plan. Okay. So Spark will it's kind of a sequence of steps, sequence of stages in our case. Okay. The first logical plan is a user created logical query plan. Now this plan goes to logical Spark SQL engine. Okay, so you may have data frame APIs or you may have SQL, but both will go to SQL engine. Okay, the moment you write any code, anything in Spark, anything you do anything in Spark, it's supposed to go to this SQL engine only. You can ask me why SQL, why this data frame also going into SQL engine. There is only one engine, that is this SQL engine. Okay, Spark SQL engine both. Okay, so both either data frame or SQL, you write anything or select a star from table or df dot select anything, both will go into the same SQL engine. Okay? And this SQL engine supposed to optimize that query. Okay, will process your logical plan in 4 stages. So here is our concept starts now. Okay, till here it's just information, but here is how it starts now. Okay, the analysis stage. The analysis stage. Okay, first stage is analysis stage. Second is logical optimization. Okay, third is physical planning. Fourth is implementation. I mean, last stage in code generation. Okay, so let's see what are these four. Okay, now let's go here. For example, let's assume select product quantity from product table. Okay, you gave this code, to the Spark. Okay, now what this will do is it will analyze this code. Is this code correct? Select, spelling is correct. Product quantity, it's not the keyword, right? So it won't check spelling for it. From, it will check for the spelling, and product table it will check, it won't check anything. But for this product table, it will go and check is there any table that is named with product table? Okay, it will check for the table existence. Does this table exist? Okay, now it checks that it presents. Now it comes here and it will check for the product quantity. Is there this table exist? Is this table exist, and in that table is this product quantity exist? Is this column exist or not? So it will check for both the things, and if both the things are exist, then only it will pass to the next stage. Otherwise it will fail this analysis stage only. Okay, so maybe tomorrow or day after tomorrow when I start the practical classes, right? So then I will show you that execution. So then you will see this analysis issue. It was let me there we will go and give some random name here. I'll give select Ravi from product table. It will fail because there is no column called Ravi in the product table, right? So that's the analysis of for existence of the columns of the tables you give. Okay, now also one more thing, that Spark SQL engine will look into the catalog to resolve the column name and its data type. Data type as well. See, data type as well. It will look for the data type as well. Okay. Now, for example, assume you have a SQL like select the product quantity plus 5 from product table. Okay. Then what happens generally? Let's say product quantity. Quantity is supposed to be integer. Then only I will go and apply plus 5 here. Right? Product quantity should supposed to be integer. Then only I can go and do it. If it's a product quantity is not an integer, if it's a string, can I go and do plus 5 on top of that? No, I cannot do that, right? So that's why it will check for the data types as well. Okay, so the Spark SQL engine might also apply an implicit typecasting to the product quantity to perform and validate the addition operation. Okay, so typecasting. So if it's possible, it will try to do that typecasting. Typecasting in the sense like how to say, mm, let's say let's say you wanted to wait. Let me give you this. So let's say mm, num str num string is equal to you. Someone gave this like this. Okay, 1 2 3. You know that 1 2 3 is string. So what you can do is, so number is equal to num underscore str. Okay, dot cast of int. Then if you see type of this num str, it will print class str. Okay, but if you go and do the type here, it will print number here, int. Okay, so typecasting. So you just converted the data type of this 1 2 3, which is a string. If you put quotes here, right? So either the single quotes or double quotes. If you put quotes here, it will be a string. Okay, so just that we are converting it into int here. Okay, so this is what typecasting. Okay, now let's go to the next one. So if your code is past your analysis phase, that means you have a valid code and you're not using something that Spark doesn't know or cannot resolve. Right? Self-explanatory. Now, next stage is logical optimizations. If you remember, I told you in the previous classes where I mentioned that optimizations. Spark will perform optimizations. What are those optimizations? Okay, so you give the code right. You give the code to Spark, but Spark won't will read the code pass the analysis phase. Then Spark will apply some operations. Why it will apply is because let's say select a star from table where name is equal to Ravi, right? Where name is equal to Ravi. Now, does Spark needs to scan, get every record? No, right? It needs to get only where name is equal to Ravi. That means it will look for only that row and take that row. And if you are applying any transformation on top of that row, it will apply those transformations and give it to you. That means before, rather than taking, let's say there are 100 rows in your data, okay, either taking all the 100 rows now and apply filter on top of that, or while before and apply transformation on top of that, or in the first only you will take only one row from that 100 rows, and now on top of that you apply transformations. Okay, so or let me put it this way. Okay, let me take 100 rows, apply transformation on top of that, then in the last, okay, in the last I will go and filter for the name Ravi. Is it good approach? Definitely no. While you wanted only one row whose name is Ravi, then why applying transformation on top of 100 rows? It's not possible, right? Right. So That's why this optimization comes into the picture. It will do predicate push down. Okay, that's what this predicate push down means. So predicate push down means this filtering happens. Sometimes we won't write the code that optimized way, but here it will take care of that. So select a star from table where name is equal to Ravi, then it will push the name is equal to Ravi first. That means first it will go and look for in that partitions where the name is equal to Ravi. That's it. It will look for that. If it matches, then it will pick that record. And now on top of that it will try to do the transformations and all. Okay. And partition pruning. What is this partition pruning? Pruning means you have 100 partitions. You have 100 partitions, and um, you had to know this partition by and bucketing by. Okay, so partition by bucketing means, let's say, all people belongs to Andhra Pradesh, or let's all people belongs to Hyderabad. Okay, now while I create right part, select a star from table, and where name is equal to, sorry, region or city is equal to Hyderabad. Okay, we have Hyderabad and Bangalore cities here. Okay, now if I put all Bangalore related data into separate partitions and all Hyderabad related data into Hyderabad partitions. Okay, let's assume for now you have 100 records. Out of that 100 records, 50 belongs to Hyderabad, 50 belongs to Bangalore. Okay, now go on there and put that select star from table where city is equal to Hyderabad. Now, do I need to go and touch the partition for Bangalore? No, it's not needed. Why? Because I need only Hyderabad, and if I go and search for Bangalore, I won't find anything related to Hyderabad there. Okay, now I left with only 50, right? 50 records. So in the real time, so this partition pruning means avoiding the partitions which are not needed for that query. Okay, simple, avoiding those partitions. That's it. Okay, now these are the few things, like these are the few things it will apply in the background. So there is many things it will apply, but we do not need to worry about all those things. This constant folding, null propagation, boolean expression, all these things, it will apply so many things. But let's not worry about those things. Just this is a sample. It will take care of all these things. Okay, how bad you write the code, so there's still user can write a bad code, and that it cannot upload optimizations on top of that. Okay, it still happens. Okay, okay, there is starting for everything, right? So there will be a start point. So yeah, it can still happen, but almost it will try to for almost 90% it will try to optimize your query. Okay, logical optimization. So this logical optimization phase applies standard rule based optimizations to the logical plan. I told you, right? Spark developers who developed this Spark, right? They did some rules. Okay, rules. It Spark tried to apply all those rules. Okay, then that's how it prepares the optimizations, and it will prepare the plans, multiple plans, which I will tell you more on this. Okay, so we don't care what they include here. Okay, all we want to learn is they apply some logical optimizations to our code and create an optimized logical plan. See, that's it. We don't care what they will do. Okay, it's good to know concept. Okay, so we don't care what they will do, but uh, just remember that it will apply some logical optimization. That's it. Okay, now then this optimized logical plan goes into the next phase of physical planning. Physical planning. Okay. Physical planning means, what is physical planning? What is logical planning? Logical planning means you prepare the design for your building, but you are yet to implement it. Okay. You prepare the design on a piece of paper. Now we need to go and execute it. Okay. Now let's see how we are going to execute. Spark SQL takes a logical plan and generates one or more physical plans in the physical planning phase. Physical planning applies cost-based optimizations. What is this? What does this mean? That means you know what to do. Now, what you need to do, step one, step two, step three, stage one, stage two, stage three, everything. You know what to do, but how to do it. Okay, that physical execution. Physical means real execution. Till now, everything we talk about is, it's a logical and it's imaginary. Okay, but what is that real thing that happens on top of the data? So that's what this physical planning is all about. Physical planning, what happens is, it will come up with you. Let's say you go to your architect and says that I need two bedrooms. Okay, two bedrooms, one kitchen, one hall, something. Okay, you give them what you need to do, but now how to do it? Where should these bedrooms come? Where should this kitchen come? Where should this hall come? Everything should be decided now, right? So what is the best optimized plan? What is the best as per the what do we say, right? Astrology and all these things. So all these things comes into the picture. Similarly here, cost will come into the picture. Okay, so let's say this plan, right? On top of this plan, it will try to generate multiple physical plans. And if I execute this physical plan, what is my cost? Cost in the sense, what is the time, what is the network buffer, all this kind of stuff, how many partitions I need to scan, okay, how many records I need to scan, all these things comes into the picture. Okay, now we have all these physical plants. Out of these physical plants, you will pick only one plant which has very less cost. Okay, so that's what this physical planning phase will do. Okay, so you pick only one plant. Okay, so the engine will create multiple plants. Okay, calculate each plant's cost and finally select the plant with the least cost. Simple, right? It will select all the physical plants. It will select the least cost. Okay, at this stage they mostly use different join algorithms to create more than one physical plan. So they will use multiple algorithms. It has internally, it will use all those things so to create a plan. Okay. For example, like if you want to go with an example, so so they might create one plan using broadcast join. I will let you know what is broadcasting and accumulator. Maybe day after tomorrow, or if possible today only. Okay, broadcast and accumulators concept. Okay, and using sort match join, one more shuffle hash join. There are different joins. Okay, so when we come to joins concept, you will get to know these things. So out of these different joins, if they wanted to perform join, right, you mentioned that select a star from table, employees, inner join, departments on e dot department id, employee dot department id, departments dot department. That's it. Now, what is the join? You mentioned inner join, but here in Spark itself is some different joins. Different joins means it's not joins we think. Okay, no, it's not a join about the data sets between data sets, but internally. So how we are going to do that? So there are multiple places. Okay, so there is a big some 20 page document or something on top of this joins, how joins happen internally. But let's try to simplify this. Okay, but for now just think. Okay, it will try to, let's say, it gives some logic to this thing. Okay, so this part, so it will try to create all possible ways. It will try to check in all possible ways, and then it will create a separate plan, a physical plans. Okay, so let's say if this way is possible, let's say you wanted to go to your house from your office. Okay, what are the possible ways? Let's say you have 10 ways. Okay, what is the, on all 10 ways you will try to calculate a plan. Okay, now out of these 10 ways, the 10 different possible ways. Okay, so what is the best way? What is the less traffic? Okay, less distance or less traffic based on your need, right? So it should be less traffic. Maybe it took some time. Okay, fine, but I do not want to go into the stuck in traffic, so let's choose that path. Okay, if not, let's choose the least path. I mean, shortest path. Okay, so that even though I'm stuck in traffic, I'll reach my home very fast. Okay, so like that. So different paths, you will select only one path. Here it will select for the least cost. Finally, apply cost to each plan and choose the best one. So that's what we choose, the best one. Okay, the last stage of code generation. Now, so your best physical plan goes into code generation, and the engine will generate Java bytecode. We discussed, right? Internally, one thing, PySpark is PySpark is wrapper of Java or Scala. Okay, PySpark is a wrapper of Java. So whatever you do from PySpark, right, internally it will be converted into Java only. Okay, Java only. But we do not need to worry about any Java related concepts here. All we need to worry about Python related concepts. Okay, so internally it will be created into Java bytecode. Okay, and for RDD operations. Okay, because I mentioned, right, data frames are built on top of RDDs, but let's not directly go and use the RDDs. Let's use these data frames. Then this Spark will automatically optimize these data frames because of its catalyst optimizer. Okay, then it will create a logical plan. Okay, then it will try to create a physical plan as well based on the cost, and then it will try to generate the code means by Java bytecode. Java bytecode means it will be understandable by these JVMs, Java virtual machines and all, right? So, and that's why Spark is also said to act as a compiler, because it uses state of art compiler technology for code generation. I mean, you might have never heard of this, but yeah, it uses some technology, correct, for all these things. So that technology is state of the art. Okay, compiler technology for code generation to speed up the execution. Okay, so that conversion, bytecode creation, right? For that bytecode creation, we'll use this state of art. It's good to know, but not must to have. Okay, now just go with the summary of query plans. The analysis is all about parsing your code and resolving names from the catalog. That's what we saw. I told, right, select star from table. It's a valid code. Okay, select star from table. Now, if you see, if this is correct, okay, it's auto corrected, I think. Okay, this is correct. But if I go and give this select, instead of select, let me give this, then Spark, it will fail because it's not present. This is not the keyword that it is expecting. It will fail. That's what this analysis case will come into the picture. Okay. Um, and logical optimizations is for applying all rule-based optimizations. Okay, the outcome of logical plan is optimized logical plan. Okay, it will look for all logical plans. I mean, optimized rules on top of that plan. Whether I need to do filter first or filter last. Okay, like whether I need to go and scan this partition or not, because it's you do not have the Hyderabad related information. Do I still need to go and no, it's not needed. So all these things, optimizations will go and solve. Okay, the physical plan converts that we what we wanted to do into how to do. Okay, so the physical plan takes decision such as what type of joint should be performed. All I mean, I told you right, chocolate joint, broadcast joint, short mesh joint. There are three different joints. So it decides on top of those things. If it comes to joint place, but if it comes to I told you the path, right? Similar the path, it will select the one of the best path, shortest path, less cost, all these things. Okay, so should we do a short match? You can ignore this now. Just think of a path to your house from office. Okay, now the physical plan can also translate data frame operation into RTD, because everything in Spark is an RTD operation. Just remember this. Okay, so everything in Spark is a data frame, sorry, RTD operation. But let's not directly go and use RTD. Let's use it via data frame, because it will automatically optimize these RTD operations. Okay, fine. Finally, the code generation step will create bytecode for different stages. Bytecode. If you work with Java, you might have had this concept, Java bytecode. Okay. Now this bytecode can be executed by any Java machine. Okay. So it will generate the Java bytecode. So that's all about this Spark plan, a Spark engine and query plan. Okay. So any doubts in this? Okay. We had up RDDs, data frames, and data sets. Now we gone through this engine and query plan. This is just I told you only in normal words. Okay. But if you start real time and all, you can have this Spark dot. I mean that entire plan, right? You create it. You write the code, right? So you can go and see how that is being planned in the backend as well. I'll show you. I'll show you that as well in the practical class. Okay. So that's all for this Spark. If you are good, we can move to the next concept. So you guys good, right? Here. Hello. You guys are still there, right? Okay. So good, right? Any doubts? Anything so far?
No, sir.
No, sir.
Okay. You are able to. I think I believe you are able to grab something from these things, right? Something, at least something. Okay. So let's move to another concept. I mean, it's very easy concept, but just try to remember those names and all. Just a second, let me share my screen again. I just stopped sharing. There is one more concept, Spark Submit. So once that is done, we will be good for today's class. Hmm, Here are these documents. Heroes, login, acknowledgement. Okay, got it. Let me reshare my screen. Okay, and team, for everyone, for your information, tomorrow we do not have the class. Okay, is everyone here? I just mentioned here. Okay.
Yes, sir.
Okay, let's go to Spark Submit. This is the final concept we will discuss today. Okay, so yeah, this is the understand Spark Submit. Okay, so Spark Submit. Spark Submit means terminal. So if everything's set up here, okay, if everything's set up here, you can just do and type here and just press enter. Okay, then it will automatically submit your command to the cluster. Okay, so Spark Submit. I wanted to show you the image. Hmm. This is YouTube video. No. I want to show you how. Yeah, I think this is. See, if I go and give this Spark Submit application.py, it will take automatically take this. I think this is an error, but yeah, this is how this command line, right? In command line, if you do this Spark Submit something and this application .py or something, so if I able to submit this is a command line interface, right? Terminal. So if I go and give this command there, it will automatically submit my entire job into the to the cluster. Okay, so think in this way. So in the real time, you have a production cluster ready, and on top of that production cluster, you wanted to run your job, but you develop everything in your local, okay, in your local, and now you wanted to submit this job to the cluster. Then you will go and use this Spark Submit command. Okay, that's it. Spark Submit is a command line interface to submit your Spark application to run on a cluster. Okay, it can use a number of supported master URLs, okay, to distribute your application across the cluster, or can run the application locally. Okay, here is the general structure. Okay, I told you, right, the Spark has deployment modes as well: client mode, cluster mode, local mode. Generally we never consider local mode as a one of the mode because it's just for testing purpose, so let's remove that. We have only two modes: client and cluster. Client means driver program will run in your local machine, I mean in your laptop, from where you submitted this Spark Submit command, this job to the cluster. But in case of cluster mode, the driver program will go and run in the cluster. Now, if you close the laptop also, no problem. Your job will still execute on the cluster. Okay. Now, this is what the Spark Submit command looks like. General structure: Spark Submit. That's a keyword here. Hyphen hyphen class, and you will give the class here. But as we are going with the PySpark, we do not need for this class. Okay, we do not need this. Now, master. Master means the resource manager, right? This Spark Submit supposed to be accepted by the resource manager because it's yarn, right? I told you, right? Almost we will go with yarn only. So it needs to suppose with a yarn resource manager. Then we will give that master URL here. Okay, and deploy mode. It could be client or cluster. Okay, config key value. Config means if you wanted to set some parameters or some features, enable some features or something to your cluster, Spark engine, Spark cluster, then you can use this configuration. Application.jar, your entire code, you will make it in jar and you will give it here. Application arguments and all. So all we will see one by one. Okay. So class, entry point of your application, that is where your main method runs. But for Java and Scala, this would be fully qualified class name. But in Python, it's optional and we won't use this. Okay. Now let's go to master. This is the master URL of the cluster. It can be URL from any Spark supported cluster manager, for example, local for local mode, Spark host port for standalone mode, Mesos or yarn. Simple. This is what we want. Yarn. All these are the options we have, but we will go with the yarn only mostly. Okay. So list of configuration properties available in Spark 3.1. So you can just go and check it. Okay. Deploy mode. By default, this can be either client or cluster, but by default it's client. Unless you specify as a cluster, it will directly go and take the client. Okay, local mode never involved. Okay, so if you want to test it, then you might go and just write a local there. Okay, so in client mode, the driver runs on the machine from which the job is submitted. In the cluster mode, the framework launches the driver inside the cluster. Simple, that's what we discussed. Right? Now, conf. This is used to set any Spark property. Spark property. Okay. So it is used to set the Spark property. For example, Spark executor dot memory, driver dot memory. We discussed, right? So the driver memory. What is the driver memory? If I give 1 GB, it will give us 1.384 MB, 384 GB. If I give 2 GB, it will give 2.384 MB. If I give 10 GB, it will give me 11 GB of executor memory or driver memory, right? Those properties you can set it from here. Number of executor cores. Okay, so all these things you can decide from here. Okay, now this is the path of your complete Spark application. So your application, you will make it as a jar file with all the necessary libraries and all. So you will compile and you will give it as an application jar. Okay, application arguments, these are arguments that you need to pass to your Spark application. So let's say argument 1, argument 2. Maybe your job is expecting an argument, then you will give name is equal to Ravi. So start with name as a Ravi. So let's consider default value of pi is equal to 3.14, right? So we will give it, pass it here. So argument pi is equal to 3.14. Then it will take that 3.14 and use that as a for entire thing. Let's say you want to change the pi value. Let's give it as a 6.14. Something, change it. It will take that arguments. You wanted to give them some arguments. Okay, some input so that it will act accordingly. Okay. Now, this example, hyphen hyphen master local of 4 means a job will run locally with 4 worker threads, essentially 4 cores. That means if you give this master local, I told you, right, only client and cluster, but if you go with master local, the job will run locally with 4 worker nodes, essentially 4 workers. Because in most of our systems, right, it will be 4 cores. So that's why if you give 10 cores, it will fail because you will never have this 10 cores. Okay, so hyphen hyphen py files is used to add .py, .zip, or .ex files, the type of the files. Okay, the argument 1 and argument 2, that will be passed to your Spark application. Okay, so if you see Spark submit local hyphen py files means the files. This is one file path. This is another file path. Okay, and these are the arguments. Simple Spark submit command. Now understand the Spark submit command. Let's see. This is how the typical Spark submit looks in the production. Okay, so Spark submit. This is the master, because this command you gave supposed to be acceptable to the resource manager and run it, right? Where is that resource manager? Where is that resource manager? You need to send, right? So if you want to send a message to Arun, you're supposed to have his number. Otherwise, you cannot send it. Okay. So similarly, if you wanted to submit your Spark job, you're supposed to have that master's URL. That's where this is the place where you will get that. Okay. So you will get that. Somehow you will get that, and with the help of that, you will mention the master here. Okay. Now it will decide. It will act accordingly. Okay. Deploy mode client, executor memory 4 GB. Okay, so driver memory 2 GB. The name of the Spark application, you will submit a Spark application. All six of us will submit a Spark application, but we need to give some name, right? So we will specify that name here. Conf spark dot app dot name is equal to word count app, something, so some word count program or something. The executor cores, executor instances, parallelism, default parallelism. That means you can decide number of partitions you can process at the same time. I told you, right? Uh, by default, if it was able to process, if it was able to process, let's say 100 partitions, it will take the 100%, it will process it. But if you set this default parallelism, it cannot be able to take that 100 partitions, even though it has that ability, but it won't do it because you're setting a default parallelism here. Okay, so max result size to the driver. Okay, so the moment you select do some actions, right? Sometimes you need to pass this data to the driver program, but if you pass too much amount of data, the data greater than this driver's memory, then it will run into out of memory issue. So then this max result size will help you to avoid that. Okay, max 1.1 till 1 GB only the data will go into this your driver. Okay, so network timeout. Okay, so if more than 100, 800 seconds, if there is any issue or something, it will automatically cancel everything. Okay. So files, Python files, these are the Python files, py files. Master, Spark to connect to standalone cluster or the given IP address, or YARN cluster at the given IP address. Deploy mode, driver program, Spark to run the driver program on the machine that job is submitted from, as opposed to within one of the worker nodes. So I mean, it tells Sparks where it should run the driver program. So it will run on the if it's client mode, it will run on the same mission where the Spark job is submitted from. Right? See, to run driver program, client tells Spark to run the driver program on the machine that that job is submitted from. Okay, and as opposed to within one of the worker nodes. Within worker nodes, where it will happen is in place of cluster. If you go with cluster, it will happen. Okay, it will happen to run in the worker nodes. But here, as I mentioned, client, it will run in the machine where the job is submitted from. Okay, now understand Sparks. Sorry, next thing, executor memory. Executor memory is 4 GB, driver memory is 2 GB. Amount of memory for the executor and driver processors respectively. Okay, word count, the name of the application. Name of the application, executor cores, number of executor cores. Okay, so now executor instances, 5 executors. Okay, now 5 executors. For each executor, you will have 2 instances. That means it's 5 into 2. 5 into 2 means 10. So at the same time, you can process only 10 partitions. Okay, so the default set parallelism is 20. That means default number of partitions in RDD retained by the transformations like join, reduce by keep ls when not set by the user. So that means um, the moment um, the moment any value transformation happens, it will try to create 200 partitions by default. I told you, right? 200 at first, it will take the number of partitions based on the capacity it has. Now it has the capacity is 2 into 5, 10 partitions. But the moment it shuffles, right, the shuffling happens, shuffling in the sense value transformation, all this kind of stuff happens, right? Then you can decide after that shuffling, can it go and create 200 partitions? By default, it will do that. Okay, but can it create only 10, 20? That's what this Spark dot default dot parallelism will do. Okay, fine. Let's max result size. Right? The total size of serial results of all the partitions for each Spark action. This could be least as large as the largest object you want to collect. Um, this should be the least as large as the largest object you want to collect. How I wanted to say is, let's say you wanted to collect something into your driver. Okay, Now I gave max result size is equal to 1 GB. Okay. Now what it says is, let's say there are two partitions that you wanted to get into. Let's say two partitions. Okay. Out of these two partitions, it should be at least as large as the largest object you want to collect. Um, Out of these two, one partition is the largest. That may be 1 GB. Let's say 999 MB, 999 MB. One is one, let's say 500 MB. Now, out of these two, it will get only this partition two. It won't go with the partition because we set some size, right? 1 GB. And if I pick both, it won't happen. I need to take half from partition one, half from partition two. It won't take. It will try to take the entire partition two. Okay, that max results. Okay, so network timeout, default network timeout value to high 10 seconds. Configuration plays a vital role in cases where you deal with large shuffles. Okay, network timeout. So if it was network is till it will wait for 1800 seconds to establish the connection again. Right? Okay. So if my Wi-Fi got disconnected, I will wait for 1800 seconds only to get connect back. If it was more than 1800 seconds, I will close that entire laptop or something. Let's think in that way. Okay. So network timeout happens. Okay. You see that sometimes you request any websites or something, it says network timeout because you are trying to connect to that network, but it's not able to connect, allow you to connect. For you will retry for at least 10 seconds, 20 seconds, 1 minute, something. After that time, it will be automatically timed out. Okay, connection timed out. So sometimes you will face this thing, right? Connection timeout here itself. So that's a kind of a timeout. Okay. Python files, you can give your Python files here because you develop your code in and write a Python code, right? So that Python code you can give it here. This is the Python code, and the argument, right, is an argument that will be passed to Spark application. In this case, it's a path to the text file that your Word application will process. I mean, input file to that Spark application. You need to pass some input file, right? So that you can pass it from here. Okay. That's it. The Spark Submit is self-explanatory. Okay. Mostly Spark Submit we won't do. I cannot show you because for that I need to set up entire things in this laptop and all. But nowadays we are running ahead of the Spark Submit from the real database cluster. There's this database cluster. So from there we are doing all these executions and all. So I will show you from that point of view. But Spark Submit is good to know concept. Not good to know. It's very very important concept definitely, but we are not going to do any practical on top of this. But you can just go and watch some online tutorials or something. So I mean YouTube videos and all. So how things happen for this to install and everything, it will take at least 1 day for us. Okay, so I face so many issues when we install Java, we install Python, we install Spark. Okay, set up all the environment variables. Then also it won't work because our systems generally do not have that capacity to run the Spark applications. So that's why we always prefer this Spark cluster. But we do not have cluster handy. Actually, in real time, they has this Cloudera setup and all. Okay, so then they will log in and they will do all this stuff. But we do not have that setup here. So okay, so we cannot do it from our local systems. Okay, that's all. That's all pretty much for this class. Okay, so let me quickly cover one more concept before exiting. So this is still memory management and all, right? I hope you are okay with today's class. I think two of you do not join yesterday's class, Arun and Anusha, right? So please go through these concepts. Okay. So that recording, okay. I shared the document as well with the notes which was written by me. So you can just look into that as well. Okay. So broadcast and accumulators. Okay. This is the one more concept. Let's discuss this as well. Okay. Broadcast variables in Spark. In Spark, broadcasting. I told you about broadcasting. What is meant by broadcasting? That means if any cricket match is happening or any football match, any match or any sports is happening, what these TV channels will do, they will broadcast that to your TVs, right? Your TVs. So or your phones. I mean to your app, okay, Hotstar, anything, any live streaming something, right? So they're broadcasting this. Similarly, this broadcasting, what happens is read-only shared variables that are cached on each worker node. Okay, each worker node rather than sent over the network with task. Okay, so let's say there is one variable. Let's say today dollar value is, let's say today dollar value is how much? Let's see. 88.67 rupees Indian dollar value. Sorry, dollar value now. So if you wanted to, these broadcast variables will help us to broadcast. To broadcast means, let's say we have worker nodes, right? Worker nodes. Let's say you have some executors. Let's say executors will be, um, let's say five executors. Okay, five executors. I mean that are running in, let's say, two worker nodes. I told you about nodes, right? Worker nodes. Node is a big thing you can think. Inside that node, worker node, you will have small executors. Okay, so now if I can put this value, $1 is equal to 88.67 rupees in every worker node, then all the executors running inside that worker node can utilize this value, right? So that's what broadcasting means. Okay, so what happens is these companies, right, what they will do is, let's say there is a Hotstar, what they will do, Hotstar, Amazon Prime, anything, what they will do is they will broadcast the cinema. Okay, let's say that cinema, that movie, whatever it is, right, it's the top one in that entire, okay, in that region. Then what it will do is, in that country, it will do is, let's say it has five regions: Hyderabad, Bangalore, metropolitan cities, Chennai, Delhi, all these things. Now what they will do is, they will broadcast this to all these regions. They will save the local copy inside that. So next time when someone comes and asks for, want to see that movie, it will pick that movie from that region, local region. Okay, it won't need to go and pick from the central server. Okay, it will pick from the region server. Okay, similarly, if let's say, water bottle. Okay, if you have five rooms in your hostel, and every room has the water facility available in your room, then you're good, right? You can just directly go and pick it up, drink that water very fast. But if that water is not, it's in a central place, I mean only one place, then every time you want to drink water, you need to go it and refill it and come back, right? So instead of doing that, if you broadcast that water service to every water pipe to every room, then it's easy, right? Broadcasting. That's what broadcasting. Okay. So in Spark, broadcast variables are read-only shared variables that are cached on the each worker node. Okay. This value, right? Spark dollar, US dollar is equal to 88.67 rupees. So that is broadcast value. That means no one can change this value. It's just broadcasted to you. You just read it. That's it. You can never be able to change it, because how can you change it? How can you change this US dollar value? It will just utilize it. You cannot change it. Okay. Sent over the network with the task. They have used to give every node to copy for a large input dataset in an efficient manner. So every node will get a copy of this broadcast which we wanted to broadcast. Okay, Spark's actions are executed through a set of stages. Okay, separated by distributed shuffle operations. We know, right, stages. How stages are created? Different stages. Whenever when a transformation happens, a transformation means shuffling will happen. That's what it says. Separated by distributed shuffle operations, Spark automatically broadcasts the common data needed by the task within each stage. So Spark will try to identify what are the common data that needs to be broadcast for all the stages or all the tasks. Then it will broadcast the data. Okay. Let's say here, if you go to small example, this code I'm pretty sure you won't understand, but let me just quickly. Large quick up tool. So apple is fruit, broccoli is vegetable, chicken is meat. That's it. So if I find here data, right, this data I want to specify this. Apple is fruit, banana is fruit, chicken is fruit. Sorry, chicken is meat. Potato is vegetable, broccoli is vegetable. Right? I wanted to differentiate these things. So what I will do, I will populate this table to everyone. So if it has this information, it will use this. Okay, it will use this and create this thing. For potato, it do not have any information, right? Potato, and banana. So both these things it won't have. So it won't do anything with these two, but other three rest it will have some information. It will try to use it. I think this is code bit incorrect. I will look back at it and correct it. But yeah, but if you have these things in your place, okay. Now here, let's say you have everything ready here. Just a second. Okay, so you have everything here. So apple, banana, chicken, potato, broccoli. So you know everything, and you build this lookup table. Now in the data, right, you have thousand of values. Okay. Now for every value, I cannot go it, right. I cannot go and look for my lookup table. What I will do is I will use this. I will this large lookup table, right. That I will broadcast to every worker node. Now from there itself, I will refer this lookup table. Lookup table means just that value which everyone needs to know, right? This if it encounters banana, it will go and see that it's a fruit. Chicken means it will say it's a meat, like that. So it will get to know those details very quickly when you have a broadcast values. Okay, so that's what this says. Okay, so accumulators. Now accumulators means if you wanted to change that value, that broadcast value, if you wanted to change it, or you're doing something and you wanted to change that value which is broadcasted to you. I told you that you cannot change the broadcast value, but there's supposed to be a value that you wanted to change. Like all these different worker nodes are working on it on a different task, right? But all these tasks are working to do some addition. Let's say to increase some count. To let's say to they wanted to count number of rows. Okay, what they will do is they will use this accumulators. Okay, accumulators are variables. They are only added to associative and cumulative operations, and that used to implement counters and sums efficiently. Ignore everything. Just remember this: implement counters and sums efficiently. Okay, that means to take this. Let's say you wanted to count number of rows. Okay, fine. I have five tasks. That five tasks are running in different places. Now what I can do is let in the initial stage count is equal to zero. Fine. Let me show you some quick example. Okay. Let's say this is task one, task two, running in different executors. Okay. For now, let's go with different three tasks. Now let's say initial stage count is equal to zero. R1, R2, R3. Here R4, R5, R6. I mean rows here, okay? I'm not giving entire value, but I'm just giving R7, R8, R9. So you have 9 rows here. At the first, it's count 1, 0, okay? Now, what happens is this R1, right? Now, the moment you see, I need to count number of rows here. Total, how many rows here? 9 rows. So how we can do is, like if you use accumulators concept here, how we can do is, the moment you do this R1, right? It will go and check this, it will add this plus 1 here. It will 1. The moment you see R2, it will go and increase this. The moment you see R3, it will go and increase this. Similarly for R4, R5, 6. So this will become 5, it will become 6, it will become 7, it will become 8, it will become 9. Similarly, it will be 9 will be the answer. So you can there is only one value. You are not having count in place of here. That here. It's just accumulator. That means you can just accumulate. The moment you see a row, you just accumulate this value. That's it. Accumulation means one by one you're counting and everything. Okay. So that's a simple example here. Accumulate, this is how you create accum is equal to spark context dot accumulator of 0. Initially the value is set to 0. Okay, the moment you see anything, any this is a row, this is a row, 1 2 3 4 rows, that means it will become 4. Okay, so that's it. Accumulator means very small. That's implement counters and sums efficiently. That's it. If you wanted to, let's say for every, there is this, for every R1, let's say this R1's, let's say this product name or something, some name, some value. That value will count here. You wanted to see total sales happen in that day. Let's say you this Amazon had sell some products, right? So if you wanted to calculate how much amount of value it sold, how many number of products and how many number of what is the value of all those products. Let's say this is 100 rupees, 100 rupees here, then it's 200, 100 plus 200, 300, and 400 here. 300 plus 400, 700. So like that, it will accumulate that value. Okay, so that's what accumulators will do. Okay, so broadcasting is more important compared to accumulator. Accumulator, very rare cases you will use it. So that's it. With this, we covered almost all concepts here. Okay, almost all concepts here. Persisting and caching is done. Skewness is data skewness at 2 done. Tomorrow, day after tomorrow, we will discuss on data skewness. Okay, repartition collision you already know. Salting is part of data skewness. I will help you with that. Data frame data set you already know. I'll send you the document. Spark submit you know. Memory management you know. Mm, I mean this case studies and all you know. Okay, just go through this case studies again. It's very important. Okay. Any doubts? Let me know on this case studies. Broadcast and accumulators also you know. Only the concept left is data skewness and handling failures in Spark. Okay. Maybe on Wednesday we will complete both these things: data skewness and handling failures. That's it. So with that, we are done with Spark. And Thursday and Friday we will work on this practical thing. Okay, only 2 days. Okay, so try to attend to. Do not miss the classes. You might have recording, but yeah, just try to attend. Live is very important. Okay, just that's it. Okay, with that we will be done with Spark, and next week we will start on AWS S3 and all the cloud tools. Okay, that's all for today's class. Any doubts, anything, just let me know.
Yes, sir. No doubts.
Okay, so I'll share the document as well. Then please go through the document and just go through all the concepts. Okay,
Yes,
Okay,
sir.
sir.
okay.
Okay, sir.
Thank you.
Thank
Thank you
you.
all. Bye.
Thank you, sir. Thank you so much. Bye, sir.